Hi everyone, this is Dr. Santosh Kumar MB, Assistant Professor, Jain Institute of Technology, Davangere. In this video, I am going to demonstrate the experiment called transistor characteristics experiment. I hope this video will help you people for understand this particular experiment easily. The aim of the experiment is very simple: to draw the input and output characteristics of given NPN transistor and hence to determine its input resistance and output resistance and amplification factor for the respective transistors. We know that the transistors are the three-terminal solid-state device. They are specially used for the amplification purpose. So in order to know that amplification value and all, we first know about its characteristics. Hence we are doing this particular experiment. Okay. Next is, to conduct this particular experiment we required given transistor, that is SL100. DC power supplies is required, that is one is having the range 0 to 5 volts and other having the range 0 to 20 volts, and DC microammeter is required whose range is 0 to 1000 ohm microamps. DC milliammeter is required whose range is 0 to 100 milliamps. Digital voltmeter is required. Circuit unit is required, and that circuit contains the base resistance, that is 5.1 kilo ohms. Patch cards are required. So these are the required apparatus. Formula which is used in this particular experiment to calculate the input resistance, output resistance and current amplification factor, that is input resistance Ri is equals to delta VB divided by delta IB. So where delta VB is change in base emitter voltage to the change in base current, and output resistance RO is equals to delta VCE divided by delta IC, where delta VCE stands for change in the collector emitter voltage to the change in collector current. And next is current amplification factor, that is nothing but a slope, that is equal to change in collector current to the change in base current. These are the formulas which are used. This is a simple circuit. You can see this circuit which contains the two power supply, that is VCE and VBE. VCE is connected in the output region, VB is connected in the input region, and the circuit also contains the two ammeters. One is microammeter and another one is milliammeter. The microammeter can measure the base current, this is called as an input current, and milliammeter can measure the collector current, which is called as an output current. So the VB called as base emitter voltage and VC called as collector emitter voltage. The respective voltage, if you measure, we connect the respective voltmeters. And next is the emitter. You can see this is common for both the input and output, hence it is called as common emitter configuration. We will make circuit connection one by one. You can see there are two knobs, one is in the left side, another one is right side of the circuit. So the left hand knob use it for varying the VB and IB. The right side knob which is used for varying the IC and VCE. So connect the microammeter in the region of microammeter which is shown in the circuit first. Upon that, connect the milliammeter which is shown in the circuit, that is milliammeter region, that is, and then short the terminal of, and another portion short the terminal. Next is we have the single voltmeter. First connect the voltmeter to the VCE that can measure VCE. If the same voltmeter is connected to the VB, that can measure the VBE. You can see if I am connected here, it can show the VCE. Same voltmeter is connected to the other region, it can show the VBE. So next is, so this knob. So you can see the left side knob, VBE can be possible to adjust, IB can be possible to adjust. The right side knob, that is used to adjust VCE and IC. So this is the simple circuit connection. If you connect like this, we can easily complete the experiment. So circuit connection, first connect from the positive terminal of the voltage source to the microammeter and negative terminal of the microammeter goes to here, and the resistance which is internally connected till the base of the transistor, and this is the emitter and this is the collector. No need of connection of this portion. The transistor is also which is connected inside the kit. Next is milliammeter for the measurement of the collector current. You should connect this milliammeter to here. This is the connection of milliammeter, and upon that, so this is not connected here to here and here to here. Later we have the voltmeter, and you may connect this voltmeter terminal to anywhere based on the required measurement. Suppose if the voltmeter is connected in between the two terminals here and here, if you connect the here and here, this is the region called collector emitter region. The respective voltage across which collector emitter, it is a collector emitter voltage. Okay, and if you connect the same voltmeter to the base and emitter region, which measures the base emitter voltage here. Okay, likewise we can change the voltmeter in the required measurement.
Input characteristics studies is carried out by first setting the VCE to 4 volts and then change the voltmeter to the VBE region. So, and then adjust the VBE. The values of VBE is given in the tabular column, and the same value should be adjusted, and note the corresponding value of IB, and then all the values should be entered in the tabular column. This is a simple procedure. You can see in detail in the next slide. See, this is the experimentally obtained value. So this is the voltage which is fixed as a constant, that is VC is equals to 4 volts, and we varied the voltage in the input region, that is input voltage called as base emitter voltage, in the range initially 0.1, 0.2, 0.3, 0.4. Likewise, upon that we varied with a range of 0.02. So you can see the tabular column. So the base current is not initially started, it will be started from one particular voltage onwards. So with the first reading, initially we got the readings when the voltage which is reaches to 0.6 volts. So upon that the increases in the current steeply. So before that no current is measured. So upon that you have to plot the graph IB versus VBE, and then we will get the steep increased curve, and we should take the calculation of input resistance will be like this: delta VBE divided by delta IB. This is a simple calculation by plotting the IB versus VBE. So this is the input characteristics studies. The output characteristic study of transistor is carried out by first setting the IB to 50 or 100 microamperes, and then change the voltmeter to VCE region, and then adjust the VCE to the value given in the tabular column. Note the corresponding IC. In this particular case we are going to fix IB as fixed, and then we will vary the VCE, and we are noting the collector current in the ammeter. This is a simple procedure. We can see in detail in the next slide.
We will see that output characteristics. For studying the output characteristics, first is make all the meters to 0, 0. So now connect the voltmeter, that is voltmeter is here in the region of VCE. This is VCE. Okay, VCE region. Upon that adjust the current. So that current can be adjusted by varying here. So adjust the base current to 50. Okay, it is little bit fluctuating, but don't consider it. It is 50 is adjusted. Now you have to vary the voltage here. If you vary the voltage, that can be displayed here. Now this voltage is VCE. So the order of voltage you have to vary with a step initially 0.1. 0.1 is 5.7. 0.2 is 6.9. 0.3 is 6.9. Upon that you have to vary in a step of 1 volts. 1 volt is 7.1. Next is 2 volts. For 2 volts 7.1 only. For 3 7.1. Likewise you have to note down the corresponding reading by varying 1 volts in the voltmeter. So this is the method, simple method. You have to take till the 10 volts. Final value of voltage is 10 volts. Up to that extent you have to measure the milliammeter reading. Okay, this is for the first trial. The second trial will be performed by keeping once again this voltmeter to 0, 0, and then adjust here in the microammeter is 125 here. or 150 also you can take it is a constant. 150 is the adjusted value. Here we have adjusted the 150. We have to vary in the same step. Initially 0.1, 0.2, 0.3. Note down the corresponding reading of collector current, that is in milliammeter. Okay, 0.1.
So upon taking the readings of output characteristics, so all the values are entered in the tabular column. So these are the two columns which is going to be measured in the output characteristic studies for the two values of base current. For the first value, we took the base current constant as 50 microamps, and in the second trial we took the base current value as 150 microamps. You can see that we have varied the VCE. So in the range initially 0, 0.1, 0.2, 0.3, upon that we varied 1, 2, 3 like that. So we have measured the IC. So the measured IC, you can see initially suddenly increases, upon that it will reach us to the saturation. And next is the collector current in the another trial which is more because IB is more. Upon that you have to plot the graph by taking the in the x-axis VCE, in the y-axis IC. Plot both the graph in the same graph sheet. We will get the two different curves. You take the slope for any one of the curve. You make the right angle triangle for any one of the curve and find the value of output resistance by determining the value of delta VCE and delta IC. This is a simple procedure. The amplification factor of the transistor is determined by first adjusting the VCE to 4 volts and then vary the IB in a step of 10 microamps. We will note down the IC in the tabular column. This is a simple procedure. We keeping the VC as constant and we will vary the IB and we are noting the IC. You can see in detail of this particular measurement in the next.
So first is connect the voltmeter to VCE region, collector emitter region, and adjust the voltage to 4 volts. This knob is meant for adjusting the voltage of VCE. Once it adjusted to the 4 volts, so unplug the voltmeter from the region of VCE. Now the display is showing the 0 because of we unplugged the voltmeter from the VCE region, but the adjusted voltage which is 4 volts only. Next, connect the same voltmeter to the VBE region. Next is vary the base emitter voltage with a step of 0.1 volts. So now 0.1 volts, 0.1 is 0, 0.2 is also 0, 0.3 is also 0 in the micrometer reading, 0.47 is 0, means 4 is also 0, 0.50 is 0, 0.6 is 32. Now it is showing 0.60 volts, 31 or 32 microamps of current, and then upon that you have to vary the voltage with a step of 0.01. Now it is 0.6, then next one will be 0.61. 0.61 is 44, 0.62 is 60, 0.63 is 82, 0.64 is 109, 0.65 is 249, 0.66 is 491, 0.67 is 709. So likewise you have to vary the voltage, note down the current in the microammeter. So this is a simple experiment. This is for the first part to study the input characteristics. Next we will see that output characteristics. For studying the output characteristics, first is make all the meters to 0. So now connect the voltmeter, that is voltmeter is here in the region of VCE. This is VCE. Okay, VCE region. Upon that, adjust the current. So that current can be adjusted by varying here. So adjust the base current to 50. Okay, it is little bit fluctuating, but don't consider it. It is 50 is adjusted. Now you have to vary the voltage here. If you vary the voltage, that can be displayed here. Now this voltage is VCE. So the order of voltage you have to vary with a step initially 0.1. 0.1 is 5.7. 0.2 is 6.9. 0.3 is 6.9. Upon that you have to vary in a step of 1 volts. 1 volt is 7.1. Next is 2 volts. For 2 volts 7.1 only. For 3 7.1. Likewise you have to note down the corresponding reading by varying 1 volts in the voltmeter. So this is the method, simple method. You have to take till the 10 volts. Final value of voltage is 10 volts. Up to that extent you have to measure the milliammeter reading. Okay, this is for the first trial. The second trial will be performed by keeping once again this voltmeter to 0 and then adjust here in the microammeter is 125 here. Or 150 also you can take, it is a constant. 150 is the adjusted value. Here we have adjusted the 150. You have to vary in the same step initially 0.1, 0.2, 0.3. Note down the corresponding reading of collector current, that is in milliammeter. Okay, 0.1, 0.2, 0.3, 0.4. Likewise you have to vary the voltage till 9 volts. Okay, this will be the simple method. Okay, so you can take for any another value. So I will take this is into 100 micron I will fixed, and we will adjust similarly 0.1, 0.2, 0.3. Likewise you have to take the readings by varying the VCE for the in output characteristics. Note down the corresponding reading and enter the readings in the tabular column. For the amplification factor, so don't change anything in the circuit. Keep all the meters to 0 first initially. Next is you have to adjust here 4 volts of potential difference. 4 volts 4 volts, and then upon that vary the base current with a step of 10 amperes. This is base current with a step of 10 microamperes, and note down the corresponding milliammeter reading, that is nothing but collector current. So this is, you have to vary with the step which is given in the manual. So only thing we are doing, the output as fixed to 4 volts, then we are varying the input as 10 microamps, and we are note downing the corresponding current in the milliammeter. So first is, I will set it to 10 microamps. 10 microamps is 1.5. Next is 20 is 3.0. Next is 30 is 4.7.
So upon taking the values of amplification factor reading, so you can see VC is to 4 volts. We have varied the base current in the range 0 to 90 microamps with a step of 10 microamps. We have noted the value of IC in the tabular column. So the IC is also increases with respect to the IB. So if you plot the graph IB versus IC, we will get a straight line because it is a proportional behavior, and upon that you find out the slope. The slope itself is equal to delta IC by delta IB, which means that it is nothing but it's a value of current amplification factor. So upon finding these all the values, write the in this particular case. So the respective values of input resistance, that is 1.39 kilo ohm, and the output resistance, if you calculate the same value, which is comes around 16.6 kilo ohm, and amplification factor is about 150. It is not having any kind of unit. So you can compare the input resistance and output resistance. Input resistance will be order of thousands, output resistance will be in the order of 10,000s. The difference will be at order of 10,000 will be there. This will be the answer for this particular experiment.